So how do you get started? Well, I believe the first step has to be to establish continuous delivery. You have to establish continuous delivery first. And there's an organizational anti-pattern, particularly in organizations that value long-term strategic planning, to over-rotate on planning and alignment activities, but they don't have the underlying ability to ship code to production and validate their plans. So when we look at that DORA research that I mentioned, again, these are predictive relationships. We see that there's a lot of technical capabilities on the left. And over on the right, we see the increased organizational performance. We see in the green the software delivery performance that I just talked about. And one of the critical linchpins that connects the technical capabilities to the software delivery performance, which again is going to make you 2 times more likely to meet or exceed your mission goals, is continuous delivery. Now, continuous delivery is not about taking more risk. So we have a bad habit in the innovation community of telling folks, you need to take more risk, you need to be less risk averse. And the truth is continuous delivery reduces risk. It's less risky than the way we do business today. And you can see that in the chart on the right. Without validation, without continuous delivery, your project builds up risk over time, and that risk becomes exponential. Now, when you have the ability to continuously deliver, you get that sawtooth risk diagram that I show there. And this means that every single time we deliver, we can validate or invalidate our assumptions and bring our risk back down to 0. Not only does that obviously produce a lower risk profile over the life of a project or a program, but it allows you to take bigger risks up front because you'll be able to validate them quickly and, if you need to, pivot or stop. And so this allows us to get more innovative solutions and at the same time reduce our overall risk profile. Contrast that with what's called the alignment trap. This comes from an article called Avoiding the Alignment Trap in IT. And they have really great data that shows that most transformations get stuck in this alignment trap. And that's where they focus on alignment activities first before they try to address IT efficacy. And what happens here is we see this in scaled Agile framework implementations, for instance, where there's more software architects and value stream architects and solution architects than there are software developers. There might not even be any. And the process becomes the product. And so what happens there is that a majority of their spending goes towards those alignment activities and all those really expensive resources, but they don't have a means to validate any of the plans and requirements that are being generated through that process. And by the time they're ready to execute, they don't have the finances or the organizational efficiency to lay down their path to production and get software into the hands of users. And so they actually get stuck in that upper left quadrant and there's no way out because they don't have the resources and they don't have the organizational efficiency. The way that we approach transformation and that we recommend folks in government do this is to focus on IT efficacy first, establish continuous delivery first. I don't even care if the first thing you ship is valuable or not. It'd be great if your first app is valuable, don't get me wrong, but even if you can just ship a Hello World app to production with a full authorization to operate, if you can do that, you now have the means by which to establish rapid feedback loops, test your assumptions in prod, and quickly get capabilities into the hands of warfighters and other end users. And so that allows us to go into the well-oiled IT space where you see they have increased percentage points in their 3-year growth rate. And then that frees up the capital and the resources, as well as establishes those feedback loops to find great product market fit or to find a way to solve mission problems in our case, and get into IT-enabled growth, where our IT spend is actually reduced, and yet our growth rate is increased. Our ability to produce mission outcomes is increased. And another way to look at this that I think is important is you are going to get things wrong. We know in this modern cloud-native world, even the best designers on the planet, for existing projects where they're iterating and providing new features, they get it wrong 2/3 of the time, depending on the industry studies that you look at. And for R&D, they get it wrong 90% of the time. we just can't assume that we're going to be right, especially if we're thinking we're going to be right 5 or even 10 years into the future, like some government IT projects. And so instead, we want to be able to quickly cycle through those errors, those things that we get wrong, and find the really positive discoveries. But as we do that, we need to minimize tail risk. This is what Nassim Taleb calls black swan farming. And the idea here is that when we establish continuous delivery, the cost of being wrong is greatly reduced. We can build some code, ship it, and find out if it's the right thing or the wrong thing, if it's built correctly or built incorrectly. We can find that out in a matter of hours or days for larger feature sets, maybe weeks at the most. And so the cost of finding those things is very low. And that allows us to quickly find those large black swan type discoveries. And this bears out in financial data as well. The diagram on the right shows Maersk's shipping line case study, IT project with 73 requirements. I wish I saw one of those in government. I think there's about 2 orders of magnitude higher than that. But they mapped out each one of these features according to the cost of delay per week. And what they found is that these features mapped out as in a power law curve. And 3 requirements were responsible for over 80% of the overall cost of delay. But by bundling them with the other 70 requirements, it was going to delay the project, right? They had to wait until all 73 were complete, and it was going to cost them hundreds of millions of dollars from a cost of delay perspective. And instead, by employing continuous delivery and these type of modern software patterns, they are able to get those 3 features out in a minimum viable product and immediately recognize that opportunity cost savings. And so how do we achieve this continuous delivery? I kind of glossed over it initially. There's this long list of technical capabilities, and it can seem overwhelming at first. So I'm going to dive into the way we approach this and how you might think about doing it as a government organization. There's 3 initial focus areas that you need to be aware of to achieve continuous delivery. Application development has to be dialed in. You can't have just any old app developer. You really need strong app development, or if you're doing legacy transformation, app transformation skills. You need a path to production, and you need a production environment, a platform. So when you start with a platform, have a path to production, and you have really good application development, that's what it's going to take to achieve continuous delivery. And what does each of those mean? Well, let's start by looking at platform. There's 2 things to point out on this diagram. First, I want to say, before I get into those, I believe platform as a service is a prerequisite for DevOps outcomes for continuous delivery in the federal space. And what you see happening on this diagram is moving from infrastructure as a service, so basic AWS services, showing Kubernetes and what kind of that manages for you, cloud provider Kubernetes compared to a PaaS all the way over on the right. And I said there's 2 things to look at here. On the left-hand side, you see bring your own versus choose and configure, or versus what's provided to you. So when you go with a PaaS, a lot more is provided to you out of the box, which means you have a lot less to choose, configure, and maintain yourself. So it lowers the cost of development drastically. And we also see lower cost of operations, despite the fact that PaaSes come with license costs. So the FTE cost to build and maintain a PaaS is way, way higher than the license cost of most PaaSes. Now on the right, you see a different look, which is in the federal government. In order to deliver our applications to production, we're subject to FISMA and the risk management framework. And as a part of that, we have to implement RMF controls. Now, when you're dealing with an opinionated PaaS, you can have as much as 90% of the RMF controls satisfied, meaning the application teams, the delivery teams, are responsible for a much smaller subset. So not only do they not have to worry about building out their own Helm charts and worrying about how to manage their containers, they also don't have to worry about implementing a ton of RMF controls. And if you're looking at that from an enterprise perspective, it also means that you don't have 1,000 application development teams all recreating the wheel and doing the same work, the same controls over and over and over again. So by centralizing that and providing it as a service, you minimize not only the development and operational burden, but also the compliance security burden. Once you have that platform established, let's say you have your platform as a service and it's in your FedRAMP moderate, or maybe you have a IL6 secret level defense environment, you need to establish a path to production to get there. A lot of folks have been focusing on the pipelines here, but the truth is that's only one small component of what you need. So those release pipelines are certainly important. But you also need to build quality and security into the build phase and the build environment itself. So if you have code that has data protections on it, you need to protect those appropriately, not just the software running in production, but also the development environment and the build process. And then one thing that's really important here is we have to satisfy these RMF controls. And we want to shift left as far as we can on those. We don't want to build the software and then go do controls implementation at the end. And so if we have a good agile security requirements management process, like the one we usually implement with a tool called SD Elements, we're able to inject those controls that app teams are responsible for, right? Because they're inheriting controls from their underlying platform as a service. But we inject those controls into their backlog, and they're able to complete them throughout the course of development, so that when they're ready to deploy, an ATO is their body of evidence for their ATO is complete, and it is high quality, and it virtually assures that it gets assessed and authorized in a short time frame. And then we also want to build quality and security aspects into our talent management, our actual deployment pipelines, and in our operating environment, including continuous monitoring. So now you have this platform and you have a path to production, right? You've built out a platform as a service, you have your pipelines, and you have this continuous ATO framework in place to satisfy all of your compliance requirements. Now you have to build the software to deploy on there, the thing that actually moves the needle on the mission capabilities and drives mission impact. And one thing we like to emphasize first is to start with small, balanced teams. So we believe that product design and engineering should be on every single delivery team. They account for mission, users, and architecture, respectively. And that helps us create the best outcomes with the least risk.